Now, students, as it happens with most economic models, this urban model is based on simplifications to, of course, have an analysis that it's true and at the same time it's useful. Now, this model was developed by William Alonso in 1964, and it was also, other people thought about it. Edwin Mills, Richard Moth, and more recently, Professor Glaser, Mike Ken, Stephen Rossi, several others. We're going to learn the basic assumptions of the model. And from here, you can make lots of complications and model lots of behavior. So let's understand the basics. There's a center. They call it Central Business District. I call it the core, or basically the center, the point in the center. And we have a dense network of radial roads. In other words, it's not hard to get from anywhere in the city. For now, the city will contain identical households, and every household will have the same preferences. And each household is going to earn a wage, an income from work at the central business district from which they will commute. Now, each household will consume two goods: the house where they live, and then everything else. Of course, this is a numerary. And in this case, we can call it bread. So they consume either square foot of housing or bread. On the other hand, they have to commute. And to commute, they need to either consume gasoline or pay a transit fare. In each case, there's a cost in commuting. And of course, there's time in commuting, which is the opportunity cost of the time spent commuting. And of course, instead of commuting, you could be working. In this case, if you've learned a little bit about the value of time, sometimes you need to consider that the opportunity cost can be just to be in the park. In this case, we're going to assume that the person could be working. Okay. So the commuting cost is given by the cost per mile times the distance. The distance can be in kilometers, can be in miles, and sometimes in the exercise of this module we use distance measured in blocks. But anyhow, it's still a distance, it's still the length between the core, the business core, which is in the middle, and the house of the commuter, the worker, the consumer. Okay? What else? Oh, well, sometimes you need to go back and forth, of course. We're going to assume that all the residents are the same. They use the same transportation cost mode to commute. And, well, we're also going to assume that what they earn, they use it to buy their stuff minus the money that they spent commuting. So as you have to commute higher distances, you have lower disposable income. C will be the consumption of everything else that we're going to call it bread consumption, and we're going to assume that the price of bread is 1. And now the housing units will be measured in square footage. In other words, how many square footage of housing or of dwelling you'll buy, given that the price per square footage is P. And this might sound unreasonable when you're renting a house. You don't rent square footage. But people who work in real estate might know that the price per square footage is the way to sell sometimes real estate transactions involving shops or offices. So let's assume for now that that's the way that people consume housing in this world. Now check this out. The consumer would be earning Y minus the cost of commuting. And with this income, they would buy bread plus the square footage times how much each square footage costs. The utility function of the consumer is given by how much bread they consume and how many feet of housing they consume. For equilibrium to hold, it must be the case that the utility is the same all over the city. If this wasn't the case, then well, the person would just move where the utility is higher and voila, be happier. But right now, we're going to assume that the equilibrium makes that everyone has the same utility. Doesn't matter if they live near the core, far the core, consume more, consume less. It has to be the case that all the utilities are the same. Okay? Now check these assumptions of the models. So the utilities are spatially uniform, and what we're going to prove in this little video are these two main conclusions. The price of housing will decrease as distance increases. So the farther the house, the cheaper it is. And that's very intuitive. Right now, my daughter is looking for a job in Washington, and so she says, I don't care if I have to commute a lot. I need to be able to afford a house, right? An apartment, of course, or a room or whatever. So the price of housing decreases as distance increases. And the size of house will increase as distance increases. While this might not be very intuitive, and sometimes it's not the case in the real world, once we have the model up and running and we compare it with real data, this is what is happening in most of the cities in the United States. As distance from the core increases, the houses tend to be bigger. This derives into an inverse relationship between pricing and distance. So let's graph this. We have here the price, and we have here the distance. Now, for a minute, let's leave the monocentric model aside and let's just think about demand. If this was just a regular demand function, we can assume, for example, that the population is capped at 1 million, and we can organize the willingness to pay of each person according to the one who's, let's suppose this person wants to pay $3 million to live in the city. So we put her in the first place, then the one who wants to pay 2.5 million, and then here 1 million, and then here 1,000, so on and so forth. So if you put all these people organized together from the highest willingness to pay to the lowest willingness to pay, we have a demand function. And well, we could use this curve as a demand function. So let's suppose here's where we have the millionth person. This would be the price. This would be the price of housing in this city if this was the millionth person, right? And you can imagine the demand for housing in the city can increase if the city is more pleasant, if there's less congestion, if there's more parks, or if the wages in the city increase, well, more people will come to the city and the demand will increase. But right now, we're not going to complicate our lives, okay? We're going to go back to the monocentric model. Okay, in the monocentric model then, we still observe that with more distance, the price decreases. In the monocentric model, this relationship comes from the fact that the utility of every person coming from consumption of bread and consumption of square feet has to be the same all over the city. The consumer will choose C and Q to maximize utility subject to a budget constraint. So the price per square foot declines as distance increases. Consumers must be equally happy at all locations, so achieving the same utility regardless of where they live. This equilibrium is reached only when consumer utility is the same everywhere. So higher consumer costs means that the disposable income falls as distance increases because the consumer here, you have higher commuting costs, so you have lower disposable income. Okay. So the offsetting benefit is a lower price per square foot of housing at greater distances. This way, even though commuters living far away have less money to spend, their money goes further given a lower P, allowing them to be just as well off as people living closer. In other words, the lower P compensates from the disadvantage of higher commuter costs as at distant locations. There's another way to look at this. Okay, let's give 2 points. This is the utility function depending on C and Q. So the vertical axis will represent bread consumption and the horizontal axis will represent housing consumption. There's 2 lines, the red and the blue. The red line is the steep line that represents a consumer living closer to the central city location, x0, x0. The intercept to the y is the consumer's budget line equals disposable income, which is y minus tx naught. Okay, so when the footage would be 0, then this would be the disposable income. The slope equals the negative of the price per square foot of housing. This is the slope. And of course, the price would be the price of square foot prevailing here at x equals 0 in this yellow dot. So given this budget line, the consumer maximizes utility, reaching a tangency point between this indifference curve and the budget line. Okay, so this is the point with C naught and Q naught. So this person consumes this amount of square footage and this amount of bread. Now consider living at a greater distance in an x1 scenario, which is farther away than x0. The new consumer would have a disposable income of y minus tx1, right? And this disposable income is less than that of the central city consumer. So therefore, the consumer's budget line will have a smaller intercept here, as you can see here in this figure. And now, what we want to know is what about the price? If you see this slope is flatter, in other words, this P is smaller, and it has to be like that because this P1 needs to derive a budget line that allows this consumer to reach this same indifference curve as the previous consumer. So instead of being steep like the red one, it has to be flatter. Therefore, the consumer will be tangent to the utility line at Q1, consuming this amount of square footage and this amount of bread. And for this to happen, it has to be the case that the P1 is smaller than P0. Now, from the image, it's obvious that the suburban consumer will have more square feet of housing and less bread than the one closer to the core. And this means that dwelling size increases as distance from the core increases. Now, this substitution in favor of housing and away from bread is the consumer's response to the decline in the relative price of housing as X increases. X naught, which is here, shows that while occupying a smaller dwelling, the central city people consume lots of bread. This might be like elegant furniture, gourmet food, expensive vacations. However, this other person will have a bigger house. And they can have a vacation, but not a luxury vacation. And they can have furniture, but maybe not as luxury furniture. But the point is that they make such a combination that they are equally happy, whether they are closer to the core, consuming more bread and less square footage, or further from the core, consuming less bread and more square footage. Now, it might not be realistic, but here's what happens in urban economics. Every model has been tested with real data. And as long as the data confirms that this is the case, most of the times we take the model as being close to the truth. And on the other hand, as long as it's useful for decision making, well, then we use it. So these are the 2 principles that we derive from this video. As distance increases, the price of the housing will decrease. And as distance increases, the size of the house will increase. Okay,